let's discuss how to multiply matrices. But before I do, let's look at one thing we need to check first. Alright, so let's say I have matrix A times matrix B. Matrix A is going to be an M by N matrix, and then matrix B is going to have to be an N by P matrix. So what this says is that the number of columns in matrix A must be equal to the number of rows in matrix B. So the very first step in matrix multiplication is to check and make sure that the columns in A equal the rows in matrix B. The columns in the first matrix must be equal to the number of rows in the second matrix. So let's look at how we would multiply a very basic matrix. My first matrix is a 1 by 3 matrix. My second matrix is a 3-row by 1 column matrix. So my first one is a 1 by 3, and then I have a 3 by 1. The number of columns in matrix A is equal to the number of columns in the second matrix, matrix B, so we can multiply these matrices. So now that we've confirmed that we can multiply these matrices, we can start the multiplication. So we want to recognize which numbers are in the first position of their matrices. So in this case, I have that's in the first position of the row. The 4 is in the first position of the column. So what we do is we multiply corresponding positions 1 times 4. And then we move on to the next position and we add the next position. So this 2 is in my second position and this 1 is in my second position. So we will have 2 times 1. And then the negative 3 is in my third position and the 0 is in my third position. So we will add corresponding positions. That would be negative 3 times 0. So I have 4 times 1, 2 times 1, and then 3 times 0. So that matrix equals 6. This matrix ended up being a 1 by 1 matrix because I just have 1 row and 1 column that I'm multiplying. Let's take a look at your normal matrix multiplication and we'll go over the steps for when we don't just have a 1 row, 1 column matrix. So step 1 in matrix multiplication is to make sure the number of columns in the first matrix are equal to the number of rows in the second matrix. So something I keep talking about. The first matrix is a 2 by 2 matrix and the second matrix is a 2 by 2 matrix. So the first matrix has 2 columns and the second matrix has 2 rows, so we can multiply them. The second step involves what we just previously saw on the first matrix multiplication problem we did. We're going to multiply the first row in matrix A, so this row, by this column here in matrix B. So we're going to go we're going to multiply corresponding positions and add each of those positions. So I've got 1 times negative 1 plus 2 times 4. That is going to be my first row, first column in my new matrix. So the third step would be to take this first row again and multiply the rest of the columns. So there's only one more column, but if there were 3 or 4 or 5 or however many, you would take this row right here and multiply every single column. Each time you take a row times a column, so row times a column, it will become a new position in the matrix. So what we have here then would be 1 times negative 2 plus 2 times 6. Okay, so step 4 would be to move to the next row here. So this is my next row, 0, 4. And I'm going to repeat the same process I did for the first row. That means taking the row and multiplying it by each column. So I'm going to do that for the second row. Make sure you keep up with the same position. So the first position in this row is 0. So I'm going to go 0 times negative 1. And then 4 is my second position, 4 my second position, so I have 4 times 4. Okay. And then I take this bottom row here and I'm going to multiply this next column in my second matrix. So 0 times negative 2 and 4 times 6. What you're doing here is it's like you're foiling. So I take my first row and multiply each column, and my second row and multiply each column. See how that is similar to foiling? Alright, so after we multiply every row in the first matrix by every column in the second matrix, the last thing we need to do is simplify. So I'm going to start here. Negative 1 times 1 plus 2 times 4 would be 7. Here we've got negative 2 plus 12, which would be 10. Here we've got 0 plus 16 would give us 16. And then here, right here, we have 0 plus 24, which is 24. So there is our final answer to the matrix multiplication. It's a matrix that is a 2 by 2 matrix, and it is 7, 10, 16, 24.